picture this, right? You've got a medieval fortress, like this 1,000-year-old castle made of weathered limestone in southern Lebanon, and it just changes hands in the middle of the night.
Right.
Then, literally half a world away, you have this massive $500 million rocket test that just abruptly ends in a huge fireball on a launch pad.
Yeah, it just completely explodes.
Exactly. And then, at the exact same time, some of the most profitable, seemingly untouchable tech companies on Earth are suddenly flashing warning signs on all these financial trading terminals.
It's wild when you put it all together like that.
It is. Because, it's three wildly different stories happening in three entirely different arenas. But if you look really closely at the stack of research, the market analyses, and the geopolitical reports we're doing a deep dive into today, there's this singular kind of invisible thread connecting all of them.
Yeah, and that thread is that the entire world, right at this exact moment, is actively repricing risk.
Repricing risk,
Yeah.
Exactly.
Because we are watching this massive recalculation unfold in real time. The parameters for what we consider safe, what we consider valuable, and even just where progress can physically happen, all of that is shifting right now.
Yeah.
And it fundamentally alters how we assign value to emerging tech, or, how we tolerate physical engineering failures, not to mention how global geography basically dictates the flow of capital.
Which is exactly why we are taking a completely different approach for today's deep dive.
Yeah.
We're skipping all the usual tech industry drama. Like, there will be no endless debates about Anthropic versus OpenAI today.
Thank goodness.
Right. Instead, we're looking at this broader, overarching theme of the great repricing. We really want to show you how these shifting layers of risk actually dictate the tools you use and the world you operate in every day. Okay, let's unpack this. We have to start with a story that is making financial analysts sweat right now.
Oh, you mean the Morningstar report?
Yes, I'm talking about market gravity. According to this new June analysis from Morningstar, the massive hype surrounding AI hardware might, finally be outrunning the reality on the ground.
Yeah, so Morningstar just released this report that officially flags Nvidia as potentially overvalued.
Which is a huge call to make.
It's massive. And they didn't stop there either. They grouped Nvidia alongside this whole cluster of heavy-hitting infrastructure and memory companies. They specifically called out Broadcom, Micron, Palo Alto Networks, and SanDisk.
Wow.
Yeah, so the financial analysts are basically walking through the most exclusive, high-end neighborhood in the tech sector and just slapping warning signs on all the front lawns.
But see, I read through that report, and I have to admit, I was genuinely confused by the conclusion. How does a company like Nvidia get flagged as overvalued when they just posted this massive, 55% year-over-year growth in their AI chip revenue?
Right, the numbers are undeniably huge. Yeah.
And they literally just made a slew of fresh, really aggressive hardware announcements at the Computex Expo in Taiwan. The engine seems to be running flawlessly. It kind of feels like telling a marathon runner who just broke a world record that they're, actually out of shape.
Well, to understand that disconnect, we really have to look at the mechanics of how the stock market actually prices these companies. Because a stock price isn't just a receipt for what a company did yesterday, right?
Right.
It's a mathematical prediction of what they are expected to do over the next decade. Analysts use these models that basically discount future cash flows back to the present day. So when a stock price skyrockets the way these hardware companies have, the market is essentially pricing in absolute perfection.
Oh, I see. It reminds me of a massive sports contract.
Okay, yeah, how so?
Well, if a team drafts a highly touted rookie and immediately pays them the biggest contract in league history, the expectation is that this player will win 5 championships.
Right. The expectations are through the roof from day one.
Exactly. And if the player goes out and plays brilliantly, but, only wins 2 championships, they're still an incredible athlete. But strictly from a financial perspective, that contract was an overpay because the valuation demanded an impossible level of perfection. Is this the bubble bursting or just the market catching its breath?
If we connect this to the bigger picture, that captures the dynamic perfectly. Nvidia and Broadcom are performing brilliantly, but their current price-to-earnings ratios require them to maintain this hypergrowth indefinitely.
Which is just physically impossible.
Right. So the caution flag from Morningstar isn't predicting a collapse, and it's definitely not claiming the AI revolution is some kind of scam. It's really just an acknowledgement of market maturity. The initial surge of capital always floods into the foundational layer, the raw compute power, the memory chips from Micron, the security infrastructure from Palo Alto Networks.
We've built an incredible amount of that foundation already.
Exactly. And now the hypergrowth phase for the hardware itself is naturally beginning to stabilize.
So because the infrastructure is mostly in place, the premium for building it starts to cool off, meaning the capital doesn't just evaporate, right? It migrates.
Exactly.
It shifts away from the companies building the servers and moves toward the companies figuring out what to actually do with those servers.
Which, of course, introduces a completely different type of risk, because financial risk is abstract, right? It lives on spreadsheets, on trading terminals. But the people actually building the next layer of technology, they have to deal with physical risk.
And physical risk is bound by the laws of physics and thermodynamics.
Yes.
Which brings us perfectly to the Blue Origin situation. We just saw a massive physical risk materialize in a big way when their New Glenn rocket exploded during a launch test this week.
Yeah, that footage was intense.
It was a devastating $500 million setback for Jeff Bezos' space venture. And financially speaking, the timing is just brutal because their biggest rival, SpaceX, is officially filing its S1 paperwork.
Yeah, and for those following the space race, an S1 is the massive financial disclosure document a company has to file with regulators to finally go public in an IPO.
Right.
So you literally have this split-screen reality right now. One company is turning a massive rocket into a fireball on the Launchpad, while the exact same week, the other company is preparing to ring the bell on Wall Street and open itself up to public investors.
But, reading through the production notes for today's deep dive, the most fascinating detail to me wasn't the explosion itself.
No.
No. Here's where it gets really interesting. It's the immediate reaction of the aerospace engineers. Think about it. When Wall Street sees a bad quarterly report, they panic and sell. But when the Blue Origin engineers watched their rocket explode, they didn't throw their hands up in despair.
They really didn't.
The notes describe them literally immediately pulling up the telemetry data on their monitors. They started annotating the failure sequence based on timestamps, and they were literally writing fail faster on sticky notes in their workspaces.
That is just such a perfect example of the mechanical difference between financial risk and engineering risk. It is profound. To a financial trader, risk is often binary. You either beat the revenue estimate or you failed.
Right. Black or white.
But to an engineer, an explosion isn't a failure of the business model. It is the universe providing incredibly loud, highly specific feedback on the structural limits of your design.
Loud feedback. I love that.
Because a rocket is packed with thousands of sensors, right? And in the milliseconds before it erupts, it transmits a mountain of telemetry data. We're talking temperatures, pressure readings, structural stress metrics.
So it's not a total loss.
Not at all. That fireball basically just purchased $500 million worth of data that tells them exactly where the boundary of physics lies.
That is an incredibly resilient mindset, and it circles back to that question of where value is migrating. Because if that fail faster energy is the secret to pushing through massive technological setbacks, where is that energy being applied in the AI space right now?
That's the real question.
Right. Because if the hardware market is stabilizing and the chips are already deployed, someone else out there must be running sprints with all that computing power.
Oh, they definitely are. And the sprinters are operating at the application layer. The value is rapidly migrating from the silicon to the software.
Okay.
We are officially moving past the era of standard chatbots that just sit there waiting for a text prompt. We are entering the deployment phase of what the industry calls agentic workflows.
Agentic workflow, so tools designed to actually take action.
Exactly.
Zoom is a perfect example of this shift, actually. They just rolled out their new AI productivity suite, which they're calling ZoomMate.
Right.
And it bundles all their collaborative tools, so that's Canvas, Sheets, Slides, and Paper, into one ecosystem. But the major update is that it doesn't just passively assist you anymore.
No, it's way more proactive.
Yeah, it actively takes your raw, unstructured meeting transcripts and autonomously transforms them into finished deliverables using something they call agentic search.
Which is huge because the mechanism behind agentic search is a massive leap forward. I mean, standard search is just keyword matching, right? If you type Q3 rollout, a standard search just looks for that exact text string.
Right, it just finds the words.
But agentic search uses vector databases to understand the actual semantic meaning of your request. It knows that during last month's strategy call, you discussed the fall strategy timeline. It understands those concepts are linked.
Oh, wow.
Yeah. So instead of you spending 2 hours after a meeting hunting for context, pulling numbers into a spreadsheet, and formatting a deck, the configurable agents in ZoomMate actually fetch the contextual data and draft the materials for you.
That is wild. And Microsoft is pushing the exact same concept with Copilot Cowork inside their Microsoft 365 ecosystem.
Yeah, they're going all in on this.
You can give this system a highly complex, ambiguous prompt. Like you just say, prepare the quarterly board deck using the financial results from these 3 different data sources.
And the way it handles that request is exactly what makes it an agent, because it doesn't just spit out a generic template in one go. It operates in a background loop.
What does that mean, a background loop?
Well, first, it breaks your complex request down into a step-by-step logic tree. Then it independently navigates into those databases, extracts the relevant numbers, and drafts the initial slides. But the really crucial mechanism here is that it pauses for human checkpoints.
Oh, so it doesn't just run wild.
No, it stops its autonomous loop and prompts you, essentially saying, hey, here's the raw data I compiled. Do you approve this logic before I spend compute power formatting the final presentation?
That is fascinating. And it's not just for, like, middle management presentation drafting either. It's happening for deep technical work, too. Microsoft also shipped this AI migration tool specifically built inside Visual Studio Code for their Azure platform.
Oh, right, the database migration tool.
Yeah, its whole purpose is to accelerate moving massive databases from Oracle to PostgreSQL. And from what I understand, migrating from a proprietary system like Oracle to an open-source standard like Postgres is notoriously difficult because they use completely different logic structures.
Oh, it is usually an absolute nightmare of manual coding. You can't just copy and paste the database. You have to translate all these complex proprietary stored procedures into a completely new language.
Which takes forever.
Weeks or months, yeah. But this new AI tool doesn't just do a simple find and replace. It actually analyzes the abstract syntax tree of the database schema.
The abstract syntax tree.
Yeah, it basically reads the underlying logic, it flags the architectural differences that it knows will break during the move, and then it automatically generates the exact code required to bridge the gap. Our sources indicate this specific tool is literally cutting weeks, sometimes months, off of manual planning and coding.
See, I have to push back on the reality of all this, though.
Okay, why?
Because on paper, it sounds miraculous. But if AI agents are doing all the background heavy lifting, I mean, if they are drafting the board slides, attending the meetings to take notes, analyzing the database syntax, and only tapping us on the shoulder for a quick thumbs up, what actually happens to our daily work?
You're worried about human obsolescence.
Well, yeah. Are we just going to end up managing a fleet of digital interns instead of doing our actual jobs? Doesn't this basically reduce human workers to just clicking approve all day long?
It's a valid concern. I hear that a lot. But it really stems from a misunderstanding of what happens when you remove friction from a complex system. Because when you eliminate the mechanical busywork, human ambition doesn't just shut off, right? It scales up.
Okay, I'm listening.
We really shouldn't view this as becoming middle managers of software. We are looking at a radical amplification of individual capability. Think about it, when an engineer doesn't have to spend 3 weeks manually translating a database schema, they don't just sit idle.
Right, they move on to the next problem.
Exactly. They build a more complex application on top of that database.
So the ceiling of what one single person can accomplish just moves dramatically higher.
Precisely. Just consider the story from our source materials about the community college student.
Oh, that was incredible.
Right. This isn't some massive tech conglomerate with unlimited venture capital. This is a 20-something student sitting in a regular computer lab running a complex machine learning model on a completely modest laptop. And the sources describe him watching the training loss curve drop.
And for anyone who doesn't know, a dropping loss curve means the model's getting smarter.
Exactly. In machine learning terms, it means he is watching a live graph of his AI model, making fewer and fewer errors as it learns and becomes more accurate.
Which is wild because, like, a year or two ago, the compute power and the tooling required to achieve that kind of dropping loss curve would have cost a university research department hundreds of thousands of dollars.
And today, It costs them $12 a month for a cloud instance. The democratized nature of these agentic tools means that anyone, anywhere, can orchestrate complex systems that used to require entire corporate engineering departments. It's really not about managing digital interns. It's about giving a single creative mind the leverage of a symphony orchestra.
Okay, that makes total sense when you put it like that. We are delegating the friction so we can focus on the architecture.
Exactly.
But, this overarching theme of shifting risk, of power and capital migrating to new places, it doesn't just happen in the cloud or on stock exchanges. It happens on the physical map.
It certainly does.
And that brings us to how the geopolitical landscape is currently repricing risk on a global scale.
Because the abstract concepts of technology are ultimately bound by the very real constraints of physical borders, global supply chains, and infrastructure.
Right. You can design the most advanced AI agent in the world, but it still requires physical servers.
Exactly. Servers connected by undersea fiber optic cables, powered by physical energy grids located in very specific geographic regions.
And right now, the geopolitical map is highly volatile. We have two major developments in our sources today that highlight this physical recalculation of risk. First, in the Middle East, Israeli forces seized Beaufort Castle in southern Lebanon.
Right.
And just for some historical context, this is a massive strategic fortress situated on a hilltop. Taking control of it marks the deepest Israeli ground incursion into Lebanese territory in over 25 years. And this maneuver happened alongside a series of new airstrikes targeting locations in Beirut's southern suburbs.
And simultaneously, in Europe, a major enforcement action fundamentally altered energy logistics. French authorities intercepted and seized a sanctioned oil tanker that was linked to Russia.
Yeah, that's a big deal.
It really is. This seizure is part of a broader, intensifying crackdown on Moscow's shadow fleet.
And just to clarify for anyone unfamiliar, the shadow fleet refers to a network of older, often uninsured vessels used to transport oil under the radar. They're specifically designed to bypass the international energy sanctions imposed over the war in Ukraine.
Right, and seizing one of those vessels isn't just a political statement, It sends a shockwave through the entire logistical chain. It forces every other vessel in that fleet to recalculate their routes, their risk of seizure, and their insurance premiums.
Obviously, these are profound geopolitical events with immense real-world human consequences. But for the specific focus of our deep dive today, how the world recalculates risk, we have to look at how these physical shifts impact the global operating system.
Yeah.
Think about the human element on the ground. A logistics coordinator for a shipping company in the Mediterranean, or a supply chain manager sourcing raw materials for electronics.
They're the ones dealing with the fallout.
Right. When a 25-year border precedent shifts, or a major shipping lane becomes an active zone of sanctions enforcement, they don't have the luxury of debating the philosophy of the conflict. They have to instantly recalculate their daily routes, their supply lines, and their capital allocation based on these historical shifts.
What's fascinating here is how global crises and shifting borders quietly but forcefully dictate where compute infrastructure and capital can safely exist. Technology relies on stability.
It has to.
Yeah, if a region becomes destabilized, the capital required to build a multi-billion-dollar data center there evaporates overnight. If a shipping lane is choked by sudden enforcement actions, the supply chains for the rare earth metals needed to manufacture our silicon chips have to be entirely rerouted.
The world is constantly recalculating the physical risk of where progress can safely happen.
And technology is the exact tool we use to adapt to that massive recalculation. The logistics coordinator uses an AI routing model to instantly find an alternative supply chain. The supply manager relies on predictive analytics to understand which ports are still viable.
The physical world creates the constraints, and the digital tools allow us to navigate them faster than humanly possible.
The constraints force the innovation.
Which brings this entire journey full circle. We started today looking at a massive multi-layered repricing of risk. We looked at Morningstar tapping the brakes on Nvidia's valuation, revealing how the market uses price-to-earnings ratios to demand perfection.
And how capital is naturally migrating away from raw hardware and into the application layer.
Right, and then we saw a Blue Origin rocket explode, proving that pushing the boundaries of physics comes with spectacular failures, but that the engineering mindset turns those failures into vital telemetry data.
Then we examine how developers and everyday office workers are gaining access to agentic workflows. AI that breaks down complex tasks, analyzes syntax trees, and amplifies what a single person can build.
And finally, we saw how the shifting tectonic plates of global geopolitics force the entire supply chain to constantly recalculate the physical safety of our infrastructure. It is all completely interconnected.
It really is.
And that brings me to you, listening to this deep dive right now. Tomorrow, when you open your laptop and start your workday, I want you to think about that aerospace engineering mindset. How can you adopt the fail-faster approach in your own career?
It's a great way to reframe your work.
It is. When you look at the software you use, think about how you can leverage these new agentic workflows. Let the background agent draft the slide deck. Let the AI tool analyze the database syntax. Delegate the friction. Free up your mental bandwidth to focus on the broader architecture of what you're trying to achieve. Because the value in the modern economy is no longer in the busy work. The value is migrating to the people who know what questions to ask.
This raises an important question, though, perhaps the most critical one we face as these tools mature. If the agentic systems we are deploying drive the cost of making a mistake down to near zero, if digital agents can handle the trial, the error, and the iteration for us endlessly in the background, what happens to human progress when our only real bottleneck to innovation is our own imagination?
1,000-year-old hilltop castle changing hands. A fiery explosion on a launchpad generating millions of data points. A glowing terminal screen pointing to a stabilizing hardware market. The world is repricing risk, and the only question left is what you're going to build with it. Thanks for taking this deep dive with us. We will see you next time.